Prince Kumar. I completed my BTech in recent to 2025, and I am interested in embedded system, interested in embedded system. And then I have queried that what are steps I have to take from my side for in embedded system for getting more opportunity for me, for getting more jobs for me, uh, and how can I approach in embedded system? What a step I have to taken from my side, sir. And what are the different opportunity embedded system, different company, what are the different role in embedded system, embedded engineers? That type of query for me, ma'am.
Okay,
Hey, hi,
okay.
Prince.
Yeah.
Hey, uh, hi. I'll be the in charge for this, the whole workshop from here on. So, I'll be explaining the queries that you have raised now, and I'll be helpful. It would be like, just listen through the whole workshop, and we will provide you the great insights regarding how to crack the job. So, the main motto behind the what's that, like the workshop, this radio workshop is like just make someone like who might be like struggling to reach at least like who are like about to take the interviews in the especially in the embedded domains. Some might people might be struggling to answer few basic questions, and the main thing here we are concentrating is how the whole embedded system booted up and running the Linux kernel on the system. And that's the main, as a fresher, like a Prince, he has done his undergraduate from somewhere, some university. He might be not knowing that how the Linux is booting and how the Linux kernel is running on the system, right? So this is the 3-day workshop, and where we make you guys to understand how actually the whole Linux operating system booted up, and how the user space application will be running on top of Linux kernel, and how the collaboration between the Linux kernel and the user space programs that are running on the user space, how the user space applications will be utilizing the underlying the hardware. So this is the course, this is the motivation we have. So Prince, don't worry about how you gonna crack the jobs and something like that. So we are here to help you guys. So don't worry about that. So just enjoy the whole lecture. And uh, if you have any doubts and all, you can ask me at the end of the session, okay? And any other guys who are interested in asking something and who wants to introduce yourself, don't panic or don't worry about anything. So just explain. Just tell me about some people you have to find out.
Thank you so much, sir.
Yeah.
Hi, sir.
Hey, hi, Manikanta.
Sir, actually, I'm working as FPGA engineer. Previously, I
Great.
have experience.
Sorry guys, like Manikanta, you are in some noise area, so can you please make yourself available from the noise area, and like you can talk
Now
some
you can able to hear.
yeah, it is better now. So yeah, please go ahead.
Yeah, actually, I have 2+ years of experience in FPGA engineer.
Great. Okay.
Previously, I worked on Peta Linux, which is a AMD tool actually
Okay.
for
Yeah.
embedded systems.
Yeah. Okay.
So now I want to learn this Octo.
Yocto. Okay.
Yeah,
You
like
might be
uh,
knowing yeah, you might be knowing that Pata Linux is deprecated now, and by 26.2 they'll be using the Yocto, isn't it?
yeah, but I want to know one thing, like uh, for
Sure.
FPGA engineer, whether that
Mhm.
Yocto, up to what extent we need to learn that.
Sure. That is there, like the FPGA engineer. Basically, what do you mean by the FPGA? The FPGA is the hardware block where all the IP components will be configured by dumping system.bit, isn't it? So the
Yes,
system.bit is responsible for configuring all the hardware components on the FPGA, right?
yes,
That is the PL part, programmable logic. When it comes to
yes,
the embedded part, the PS part, the program processor part is there. So
process.
it's a sandwich sort of thing. We'll be having the both PL and PS part on the single chip. That's where like the whole hardware comes into the picture, right?
Yes.
You know the what I mean to say is, so there is a
Yeah, yeah,
PL
I
part
understood.
and the PS part. So while utilizing the PS part is the one where the actual Linux is running. You might be knowing that, right?
Yeah,
So where the PL part is the one will be having
our
the
actual,
hardware, everything is in there, right?
yes,
So for you guys, you'll be configuring the netlist on the PL part so that all the required IP blocks are up and running by just flashing the system.bit on the PL part so
yes,
that it is up and running. Whereas coming to the PS part, we have the Linux whole boot process. By the end of today's lecture, you'll be understanding what is PS part, how this PS part and PL part will be integrated, and what sort of significance does it have you guys to understand about the learning about the Yocto or like a sort of embedded systems, embedded software development, how it is like integrating with the hardware design. So such sort of understanding you will be getting by today. Okay, so just be with me and I'll make you to understand and how important is that for you guys who are working on the FPGA domain, especially in the FPGA domain to learn about the embedded applications like make a system to complete from zero to make the Linux kernel running on top of the whole PS part and how it is integrating. You will be getting the whole sort of idea by the end of this lecture. Okay, okay, Manikanta.
yeah, thanks for
Yeah,
helping.
great. So I encourage you guys, like if there are people like Manikanta and Prince, they have raised their queries. If you guys have such sort of queries, I'll be explaining you and what sort of motivation does you guys to make this course helpful for you in terms of building your career. So I'll be doing it for you guys. So please raise your voice and I'll be dedicating the next 10-15 minutes for you guys to say the same because this session must be interactive and I want you guys to speak up. That is what actually we expect you guys. So hi, few people said like they're also working. So can they ask their questions why they want to learn and what sort of significance does this workshop or the program that the ProV Logic gonna launch? Yes, the
Good
recording
evening,
of this
sir.
session. Okay, hi Madhuri. Yeah, please.
I'm Audrey.
Yeah,
So,
hi.
I am the third year EC student
Okay,
from
great.
RVRJC Guntur.
Okay,
I'm
yeah,
interested in embedded systems and VLSI. I want to
okay,
know what are the career opportunities in embedded systems.
okay,
So, I want to join this workshop. This is the
great.
first workshop for me to know about embedded systems, and I really want to know what are the roles in embedded systems.
Okay. So, you said like you are interested with embedded systems and VLSI. Those are like completely different domains. But when it comes to the application, to the user who are using the hardware components, it would be the combination of both the embedded systems and the VLSI. Okay. So, when it comes to the opportunities, you can climb the ladder when you're into the embedded systems very quickly. And if you are into the VLSI part, the sort of understanding would be somehow critical. But when it comes to your passion and when it comes to your commitment towards VLSI makes you to success very quickly when you have that sort of understanding and when you have such commitment. Okay. So I don't think both are different as a system software engineer or FPGA engineer or a design verification engineer. So only the broad spectrum, the broad understanding regarding the hardware components. While working as a software engineer, it would be a great bonus point on their profile, so that they will be concentrating more on hardware. While if they have the hardware configurations and if they know what sort of hardware, hardware components integrate together, make the running OS or software on top of the hardware, makes it useful and something like that. So it's a both combination sort of thing, if you get me, or else for you guys, like especially in the third year of your bachelor's, you might be having a great confusion. So the thing
Yes,
is
yes.
yeah. So the thing is when you are into suppose I can say, like if you are into electrical background or any ECE background, for you guys, you'll be learning a lots of hardware components like EDC, something like electronic devices and circuits,
Yes, yes.
and linear integrated circuits, the pulse and digital circuits. So you might be knowing how the transistors and how a millions of transistors integrated. You might be knowing an op amp, MUA741, something like that. So how many
Yes, sir.
transistors are integrated into it. So these sort of thing, on a hair follicle, will be integrating millions of transistors, so that you'll be knowing. It might be makes you to show some interest regarding how these minute small things are integrated into the things. But when it comes to the principles of the physics, how these things are applicable when it comes to integrating the millions of transistors on a very small area of chip, that might be challenging. But if you're passionate about learning the physics for semiconductors, that would be the great part for you to start your career into the VLSI. But and also on the other side of the coin, if you are interested in learning the code, and if you have analytical thinking and the ability to solve the puzzles, and if you're much more interested in terms of looking most probably on a simple way, I can say, if you are a problem solver, it would be great for you to start your career into the embedded systems. So if you would be like thinking the problem from all the perspectives, and you will be finding the solution. So every micro instruction, if you consider while solving the problem, it would be you to enter into the embedded systems. So that would be the greatest part on your career. So I hope I have answered your question.
Thank you, sir.
Yeah. So it's almost like 22 minutes from the point we have started the session. So what actually is if you have any further questions, I'll happy to answer at the end of the session. So I'll start the session, and yeah. So hi everyone. I'm Banu. I'm working as a system software engineer, and I'll be your session in charge, who will be take care of this 3-day workshop. And also we are launching a great program for embedded systems, especially for the people who wants to seek their career into the embedded systems. It's a job-oriented training, and this 3-day workshop, the motto behind the workshop is we're gonna filter out the people who are enthusiastic, and the people like Manikanta, who have done his who is working as a FPGA engineer right now, will be much more appreciate the people who are into working domain, and if they wants to seek their career into the embedded systems, because the ladder you can climb, the hikes, and the thing, if you are into the software domain, you can easily climb the ladder like anything. So that's where people show much interest regarding the software rather than the hardware. I don't think it's the hardware who won't get much salaries, but it's when it comes to the piece of a freedom in terms of exploring great things, it would be the software rather than going with the hardware. If you want to excel one IP component in the hardware point of view, it may take years and years. But when it comes to the software part, if you want to excel any part of a Linux driver or any like any a Linux kernel or any scheduler, kernel scheduler, if you want to, it would take it won't take much time, but it would be having much significance in terms of your career enhancement. So yeah, so this would be like this will helpful for the people who are working right now as a hardware engineers and wants to seek their career into the embedded systems like that. So yeah, and I'll jump into the session and I'll share my screen. Can you guys let me know if my screen is visible or not? Huh?
Visible, sir.
Hi, Prashanti.
It's a visual, sir.
Uh, yes, it's visible.
Yeah, so if
It's
you want to say
visible.
something,
That's it, Banu. You already introduced about yourself, right?
yeah,
Guys,
yeah.
please try to attend this 3 days workshop. This will be very helpful for you because the content we have designed for this workshop is really useful and it is industry level. Okay, not like a basics. It totally in a industry level. So definitely you will get the hands-on practical knowledge what actually the embedded developers are doing in the top product-based companies. Okay, the Banu is also from top product-based company, and we don't want to reveal the company name. Okay, so it will be very helpful for you. Please follow these 3 days. Okay.
And after 3 days workshop, we're gonna like if the people register for the placement sessions, we'll be like start listing the people. Like how many members are we interested, right? Prashanti,
Actually,
what's the
Banu,
num?
we
Yeah,
are not taking everyone for that. We have the interview because it is an embedded developer role, right? We are not
yeah.
considering everyone. There will be a
Okay,
interview for that who are qualified. We are taking only 10 members for the training. So it is not for
okay,
all.
okay, okay,
Yeah.
okay. So what are the prerequisites for the people you want to select?
From this workshop, whatever we have discussed and related to the embedded systems, like very basic questions, we are going to have a test and
Mhm.
also one interview will be there. So whoever selected in that interview, those only qualified for this training, which is for embedded developer position.
So what, like, and also we have a discussion with some vendor, right? So they want
Yes.
like 10, like they have 10 positions.
Yes.
So what about that one? Like with this, like
Actually,
we have.
we
Mhm.
got the placements from Honeywell company and different. There are only 10 positions available for the developer role.
Oh,
For that
it's from
purpose
multiple
only,
vendors,
we
right?
have yeah.
Mhm.
For that purpose only, we are taking this. We started this training to take the best 10 candidates, and we need to train them, and we need to give the placement for them. That's what
Okay.
actually is. We are not taking bulk students.
Okay, 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 guys. Like the interview would be okay. What actually the point is here? So the workshop we have launched. Most of the thing is like I'm here to cover all the industry relevant things. The work what actually we are doing day to day. So I'll be showing up to so these the whole 3 days workshop will be like booting the Linux kernel. Up to that, like what actually when you switch on the power, from there on till you see the Linux console. So what actually is happening between between the scenes, like from the power on to the Linux kernel. So it is called the boot flow process. So it is a great topic for every individual to learn. So it makes a crucial, in terms of like in terms of filtering the candidates based on their knowledge regarding the boot flow it will play a crucial role in terms of filtering the candidates. If you guys have a great understanding about the boot flow that we explaining in the next 3 days lectures, so it would be great helpful for you to clear the interviews. So with just only the boot flow process will make you to place in some product companies. So that is where it is not that easy for everyone to understand how the Linux will boot from like from somewhere like SSDs to till the whole you can see the Linux console on the system. So that is where like the complexity comes into the picture. So, and also along with this, will be I'll be giving you hands-on, teaching hands-on how to build your own software from scratch. So downloading the kernel source code from the upstream, and how you will be making, like, building up the source code to bootable images using the conventional method like toolchain, with the toolchain, and also with the Yocto build system. So the Yocto, it's like a booming nowadays, So Yocto I'll be giving you the hands-on regarding, I'll be explaining the classes, layers, and the recipes, how it is defined, and how the source code will be compiled in the Yocto. Also will be providing you on the third day. So we'll be using the BeagleBone. So that's where, every recruiter interested, because the BeagleBone is like hardware component. It is developed by the Texas Instruments. So you'll be knowing the architecture and the exception levels that is there. I'll be explaining the exception levels. It's a very complicated topic, and it's a very useful thing for someone to understand about the Linux kernel. Well, especially the user space applications are integrating with the kernel to utilize the hardware, underlying hardware. Okay, so don't take this course that easy, but just dedicate yourself for 6 hours to understand the components that we cover in this workshop, and please be eligible yourself. There will be an interview. So we from here on, this is our very first workshop from ProV Logic on embedded systems, and we'll also launch few more workshops, as the opportunities keeps on booming, in especially in the embedded domain. If someone is talking, can you please mute yourself? Okay, so it is not the first and last workshop. We'll be launching it frequently. So to just, we'll provide you the basic understanding, and we'll provide you the requirements for the interview that you will be shortlisted for the interview taken by the ProV Logic team, and they'll send you for the placement. And it is the ProV Logic's responsibility to make you placed in such 10 positions. So that is what the agenda and the motto behind the ProV Logic's webinar on embedded systems today. So can we make a move?
Yes, sir.
Yeah, great. So as she already said that, this is the workshop, and the program we are launching from the ProV Logic. It's for working professionals aiming to build their strong embedded system fundamentals, and grow as a C programmer, and wants to develop the system software. So while excelling the concepts like boot flow process, and building build systems, how you guys gonna utilize the tool chains to build the source code, and how tool chains will be utilized to compile the user space applications that would be run on top of the kernel, booted kernel. So it would be providing you the great insights regarding the course. Okay, so from here on, we'll quickly jump into the agenda of the session one. So here, the session one, today's agenda is I'll be explaining the Linux bootloader process from power on to the user space initialization. So, and the concepts that would be highlighted here are like the bootloaders and the Linux kernel. And from there on, what sort of a significance does the root file system will be having, and hands-on with the conventional Linux build. So the Linux build will be taking place tomorrow. So today, just to make yourself comfortable with the components that I covered today. I'll be giving you some sort of time
Banu,
today,
just a
and
minute. Can you please put the screen in full mode, like PPT in full mode?
okay, sure. Yeah, is it good now?
Not like that. Down there is option. Yes.
Okay, cool. Then I'll give you a great understanding regarding the boot components today, and I'll explain you the boot flow and significance of each and every component, and also I'll be explaining the Linux source tree, what actually the components in the kernel to build complete kernel image, what actually the components involved in terms of building the full kernel image. I'll be explaining you the source code and the source tree of a Linux kernel today. So just make you to and also like see one more time this video after finishing this session, maybe tomorrow at any time, and also attend the same time tomorrow. The same time tomorrow we'll be having the second session, so that we'll be working more on like building the source code from we'll be building the bootloader, and we'll be building the kernel, and also we'll be building the root file system, so that we'll be booting the images onto the BeagleBone. Tomorrow is the second session. We'll be booting with a conventional method, and the day after tomorrow, on the third session, we will be building the images with the Yocto, and I will be flashing that images on the BeagleBone. So just like I'll make you to guys, this is the very complicated and very useful thing as a professional every day. So embedded software developer who are working on developing the embedded Linux, it's a day-to-day job for someone, for someone to work on any embedded system. Manikanta, you'll be booting the board every day, and you'll be running the PL part to just verify the PL part, whether it is collaborating with the PS part or not. For that, you need to boot the board, right? So the PS part, right? So the PS part is nothing but the Linux running on the PS part. So this is how you will be knowing it. So if you can understand this concept, and every recruiter or every vendor who wants to hire you will be this will be like a trump card on your profile. So if you have this the bootloop process on your resume or your profile, it will boost you like anything. So even like I have seen multiple freshers who just know the bootloop. Hello. I have seen multiple engineers, freshers, with just a general concept from C, like if they can able to understand the pointers, and if they know structures a little bit, and just few basic concepts into the C programming, and if they can understand the logic, if they can able to construct the logic and solve puzzles, and along with such concept, generalized concepts, if they know the Linux bootloop process, they are into the company, product companies, and they are making good amount of money nowadays. From my side, you already have done your bachelor's, so that you have done some C programming or any programming in your older days, previous days, like before joining this course. You have done in your college days, or even in your job daily. You'll be writing some piece of code, so you will be knowing it. And on top of that, what you don't know is the Linux bootloop process. So I am here to make you guys to understand the Linux bootloop process along with the C, along with the programming knowledge you have previously. So this is a combo. We'll be mixing up, and we'll be sending you to the interviews, so that you'll be cracking them. It is our responsibility for you guys to crack. So now it's like maybe like before Pongal or even after Pongal. So we'll be having 10 opportunities right now. We'll be filtering 10 out of the people who have joined today and who have finished their course by the third day. So we'll be filtering only 10 candidates based on the interview, based on their interest. So we'll be sending them to the interview, so that they'll be clearing it. Okay. So that is what the agenda. And so when come to the next slide, as I have said, like I already cleared about the agenda of session 2, and also have cleared the agenda of session 3. Okay. And when quickly comes into the course, uh, what actually Linux, and how Linux is useful. Like what we have multiple voices that are there in the market, but why we still choose Linux? So we have Android, we have Windows, and also we have a lots of OSs that are there. So Mac OS is there. So what makes Linux to choose? What makes the Linux you to choose to run your applications on top of Linux? Can anyone give the answer? So if they are working, if they were working on the Linux, that would be great. Out of any, like we have got here 88 people, is there any So is there anyone who have started working who are working currently on voice?
Hi, sir. I'm a third year B Electronics and Communication student. I'm using
Okay.
Linux, sir, because I have low
Hmm.
configuration PC. I have researched a few which OS is suited for my PC, and I have found that Linux OS consumes much less resources than other OS. So
Hmm.
I started using Linux.
So you are part correct, and like I don't say you're fully correct. You're just half correct. So you're saying like Linux utilizes resources very less. That's not correct. It's all about the process that you're running. But you chooses Linux over Windows and any Mac OS. It's you. Like that would be the great choice in terms of choosing the Linux because Linux is the thing. It would be really hard for someone because from our school days onwards, if we have some computer knowledge, we'll be building everything on top on Windows itself, right? So we'll be knowing where what's the start and how actually we'll be running the Windows, and it's like GUI. So the graphic user space interface is the thing we'll be seeing everything, right? So but when it comes to the terminal, when it comes to the window Linux, it's the command prompt everything. So whatever we want to do, we can do from the command prompt itself. So that's why the user felt not comfortable with the Linux. But as a developer, like someone right now he spoke, right? So as a developer like me and few other people who are into the embedded systems, they choose after working a few days into Linux kernel, they'll find themselves comfortable with Linux rather than with the Windows because Linux is the one richer feature rich. Like you can utilize the hardware like anything. And the secret part is like most of you people don't know that the Windows and the Android, whatever the OS that would be developing on top of Linux. That's the secret, and that's the biggest part. You have to know. So I'll be sharing my screen and I'll draw that for you. I'll make you to understand. Can you able to see my black screen?
Yes, sir.
Yeah. So you know, so this is the Linux. On top of wrappers will be created. So Linux, and on top of some wrappers will be created, and some of the programs like some of other applications will be just on top of Linux. Some other features will be added. So and it would be like the features might be developing from Windows, Microsoft, or the features might be developing from Apple. So this would be like if it is like the features are developed on top of Linux, by the Microsoft, then it is Windows. If it is by the Apple, Microsoft, if it is Microsoft, it is Windows. If it is Apple, it is like iOS or Mac OS. Okay, so the thing is like Linux is it's the first foremost Linux operating system. On top of that, the Android and the iOS and the Windows, such sort of operating systems will be developed. So these all are the wrappers that are developing by the product-based companies like Microsoft and Apple and Android. Uh, so Android, so something like that. So they'll be developing their own customized OSs on top of the Linux, and they'll be naming it as Android, Windows, Microsoft, iOS, and Mac OS, something like that. So you got me right? Hey,
Yes, sir.
okay. So that is why like we have chosen the Linux. So and also the Linux is it is simpler. It is the whole total code was developed in C. And if you have a great understanding regarding the C, you can able to understand the kernel functions that are implemented in the main source code of the kernel. So it is like a portable for any hardware. So if there is a new hardware that comes into the market, Linux is the first choice of selection for vendors to run the operating system. Hello, hey Tarani, can you please mute yourself? Hey, Tarani. Okay, so if there is a new hardware that comes into the market, they for each every the hardware vendors will choose the Linux over Microsoft or any other Android component operating system. That's because like it is compatible for every hardware that the newly introduced hardware in the market, and strong user permissions and community driven patches. Like user permission in terms of security and the user permissions. So it is like a security in terms of security. We can develop a feature-rich security features from the Linux. Foremost thing is like I have to highlight here is it's open source. It is easily available in the market. Like it is free and free of cost. You can download the whole source code. On top of that, you can develop your own features. Whether if you want to develop a kernel scheduler, or if you want to write a Linux driver code, or if you want to develop any sort of if you want to contribute anything for the freely available source code on the I'm going to show you that the Linux source tree, which is like you can easily download that freely. I am going to show you that again today, and it is freely available so that you can customize like anything. You can add whatever if you want to test any some hardware any feature that is there in your OS feature, so you can test it like anything. Easily you can test the feature. So if you have the hardware, if you want to test the hardware, so the Linux is the first choice of selection by any hardware vendor. That's the most important thing you have to understand. Okay. Scalability and reliability. That is what I have said right now. If you just boot your system with the Linux, it can run for any number of years, several years. You don't need to reboot your system like anything. Suppose if you have installed Windows on your laptop, so if you have continuously used your laptop for 10 or 15 days, it will be sending you the notification to restart your system, or like you have to shut down your system, because it won't show you that reliability in terms of continuous usage of that particular operating system. But when it comes to the Linux, you can run the system for many number of years. You don't need to restart your system until unless you see kernel panic or kernel crash. Okay. So performance, as I said, as I said, like this is the in terms of performance, it works like a beast. So on top of the Linux, as I have said before, Android and everything is developed. So like the performance that the Linux provides is like it works like a beast, like anything. So community support. So I'm gonna show you the source code in the next few minutes. You can see how many developers are there who are working, how many commits are there in terms of a Git branch it is, right? So multiple people who are developing from the world across, so they'll be pushing their patches to the Linux source code, so that they'll be developing like there are like so many developers out there who are working on the Linux. So the support that you can get from suppose if suppose nowadays it is like 6 point we are using 6.12 and 6.18, and also like a seventh version nowadays it is running on the Linux kernel. So whenever if you can see LTS when you're downloading long-term support, if you see, so it will be like supported for a long time. So there is you don't need to panic if you see any issue with the kernel that you're running. So there will be like a long-term support will be provided, and that is what like a community support here it is. And portability runs on multiple hardware. So that is what I have said before. So portability, when it comes to when the new hardware comes into the market, so the Linux is the first choice of selection in terms of OS. It can be running on the hardware. Okay. So up to here, any doubts?
Sir, patches means I'm not getting your point.
Prem Kumar, your
Yes, sir.
uh, Masaram Navi, I'll just first give some insights regarding the comments in the chat box. So does postgraduates are also eligible for this session? Obviously. So if you want to seek your career in Linux, you are pretty much eligible. Okay. So yeah, Prem, Yeah, please put your question.
Patches means what is patches? Something you said
Patches.
in. Yeah, yeah.
Okay, so the patch I said, right?
Sir.
Uh, is this what you said?
Yeah, yeah, yeah. Yeah,
The patch.
yeah, sir. Yeah.
So community-driven patches, that's what you are asking, right? So the patch is nothing but suppose I have developed a feature. Okay, so for example, you know the printf, you have used the printf in your
Yes,
day-to-day
yes.
life, right?
Yeah.
So if you are a programmer, you will be using the printf. For example, suppose the printf feature that I have developed on the kernel source code, you know. So if it is only if it is like if I want to print a string, you know, so I'll be using percentile s, so that like I'll be like I'll be like only printing the string rather than printing the numbers or rather than printing any characters. My printf statement is only having the feature that it can only print a string. If you are enthusiastic, if you want to go ahead and wants to develop a feature that you can also print a character, if you can also print a long number, integers, anything, whatever you wants to print, you can print like anything by like you know if you go ahead and develop the feature printf not only for the strings, if you develop the feature to print integers and the characters like that, you know. So the features that you have developed is the version 2 of printf, right? So you have make it to upgrade to the second level, and you have added the features like to print characters, integers, and everything. So that is the changes you made from your end. And so that, you know, if you have the proof of concept saying that your printf can able to print all the integers, characters, if you have the print, and if it is eligible to merge into the master code, that is where like you can be creating the patch by using the git diff, or multiple ways are there to create a patch. So that like your source code, whatever the source you have developed, whatever the feature you have developed, you will be creating the patch for that, especially if you have made only if you suppose I'll tell you here. So suppose this is the source code. Can you able to see my screen now?
Yes, yes.
So this is the source code. It is already there. Suppose this is having the whole printf. Okay. Suppose you have added a few lines in middle, or a few lines you have added, and if you diff the source code actually available. So this is like 1.txt is the diff. So it is available. The initial file is 1.txt, and you have added few lines in the file on the 1.txt, and it will become like it will be having another version. It is like second version. So it will be like you will be like saving the changes, and if you it is like you know you'll be creating the patch by using the git diff. Okay, suppose git diff, uh, you are saying it is already available in the git repository remotely, right? You know how to use the git,
Yeah, sir. I know.
you know, right? So here this is remote and this is local. So you are like this is the file printf. Suppose if this is the printf logic you have defined. So the printf logic you are like cloning the whole total repository from remote to the local. So the replica of the remote will be there in the your local branch, right? So you have the local thing. So whenever you made the changes on this thing, you know, the same file, you know. So you when you say like a git diff and the file name, suppose if the file name is printf.c, so then it and you pipe it to when you send that to the patch, you know, so then it will create the patch. So whatever the lines you have added here with the line numbers, it will be sending the patch as a patch file. Okay, so this patch file having will have the metadata saying the file name you have made the changes, and the line numbers you have added, and whatever the content you have added, the lines, you know, everything will be having that on that patch. So this is what the patch. So if you have such patches developed from your side, it would be easily pushed to the Linux source code, and the developers like who have the authentication. Suppose in the Linux, Linus Torvalds, he's the one, Torvalds, he's the one who would have developed the Linux. He's the one in charge of merging if the feature that you have developed is valid, and you have the proof of concept regarding explaining the printf features that you have developed. Apart from printing only the string, you have also made the features added the extra features like working it for like printing the characters and integers. So it would be like, it will be merged into the master branch as it is like enhanced, right? So on top of your name, there will be another commit. Okay, you got me, right?
Yes, sir, got it. Understand.
Yeah. So, and one more question in the chat box. So, which team we will teach from basic C language? Okay, so through Linux is open source, how it can be secure rather than Windows? That is how. So Linux is open source. That's a very important question. Who is Pravina? So Linux is a open source. How how it is secure in terms of using the feature. What we mean to say is like Windows never allows you to read their CMO files or like their source code, but the Linux allows you to. That is how you will be downloading the whole source code, and I'm going to show you in the next few minutes. That is why how the security features will be implementing from the Linux. As it is source code, you will be developing the security features from your side. You will be never pushing that into the source code, right? So the security features that you have developed from your side, it is like specific to your organization. So you will be never pushing it to the kernel source code. You will be utilizing that one. You got me, right? Okay, so comes when it moving ahead. So
Uh, Hi Banu, sorry to interrupt. This is
okay, great.
Shreyas here.
Space, hi.
Yeah. Uh, so my doubt is that is the kernel same for a Linux subsystem, example Ubuntu, and custom embedded Linux? So or also there are variations in the kernel. So as you
Correct.
explained that there are customizability options to the kernel.
Yeah,
So will the
yeah.
kernel remain same?
Obviously the same, but the versions that they are using, if you say Ubuntu, for my convenience, you are using Ubuntu on your system, and the customized Linux that I'm developing is like suppose I'll be downloading the my source code from the upstream, so that it's my choice of switching among the versions of the code. Like if I want, like there will be the tags, right? The git tags will be there. So
Okay.
if your Ubuntu is based on some version, like Ubuntu is a community where like they'll be utilizing some version number 4 dot 1 dot something like that, right?
Yes.
So if I'm
Yes.
utilizing Red Hat on my side, so there also it's a customized Linux. So Ubuntu is different from the Red Hat Enterprises Limited, and CentOS. If you know that, CentOS is also developing their own Linux. So it is their vendor specific. So if you are a starter, Raspberry Pi also have Raspberry OS is there. So they will be utilizing so their own OS which is based on the Linux. So it is the Linux. The way it works is different. It works is same, but the versions that we are using. So suppose Linux nowadays it is like 6.12 and 6.18 we are running currently. So that is the latest version that we are using. Most of the companies are trying to upgrade to 6.12
Okay.
from 6.12 to 18 nowadays they are using. But if you have Linux machine on your system, if you just go onto the terminal and if you just enter uname -r or uname -a, you will be seeing the version that you are having. It doesn't mean so the Linux the features that the Linux, whatever the Linux we are using, so the operating system we are using as a Linux, it will be having the same features, but in terms of the basic, like if you are using 5 version 5, you will be having using the version 5, and if I'm using the 6, whatever the features that you have from the version 5, I'll be having the version 5 because I'm using the 6th version, right? On top of that, I'll be having extra features in terms of security or in terms of network, some from 5th version to 6th version, if the developers from the open source community have pushed into the 6th version, that would be
Got it.
available on the 6th version that I'm using. You suppose if you're using your smartphone, every 6 months you'll be getting you'll software
Yeah, OS
updates, isn't
update.
it?
Yes,
Exactly. That is what the Linux upgrades, how it works. Okay,
got it.
you
So
got me
they're
right.
basically
So
updating the kernel version, right?
correct.
And also
Mhm.
maybe also adding some other feature as well. But the Linux
Yes.
source code remains same, right?
Yeah. That's correct.
Got Yeah. Okay. Got it.
Yeah.
Okay. Thank you. Thank you.
Okay. Okay. So, uh, okay, so like this PPT will be provided for you. So these are the stuff you need to understand from your side, because as we are running out of time, there are lots of things that are to be covered from my side. These are the steps like where we are using the Linux, and that's the basic stuff everyone can enable easy to understand. If you can't get it right, tomorrow we'll be dedicating 10 to 15 minutes for the recap on the previous slide. So this is where like the interesting facts about the Linux. You just read it and feel yourself like, wow, how Linux is booming nowadays. So you can feel it. And common embedded applications are using Linux. You can see like infotainment systems that are running in your cars, ADAS, and consumer electronics like smart TVs, routers, and set-top boxes. So this is where the raw Linux you can see on the smart TVs and infotainment system, ADAS, and the routers, set-top boxes. Wherever you go, use these applications. There the raw Linux is running on, and the industrial automations like PLC and robotics. Medical devices like monitoring systems. Suppose if you can see like the endoscopy sort of thing, you'll be having the camera that will be sending into the human body, and you'll be watching if you want to diagnose the disease, and if you want to see the internal body parts, how it is working actually, human organs inside the body. That camera will be sending the miniature camera that would be sending via mouth or from the nose, whatever, wherever you will be sending, right? So the camera to just to like that is integrated with the operating system called Linux. So because Linux is that accurate, like it is compatible for the hardware. So Linux is a minimalistic, so that only for the camera driver that would be running. The hardware component that you are using is only the camera over there, so that the camera will be integrated with the Linux kernel. So will be that is the minimalistic kernel subsystem that is running on your endoscopy device, so that you'll be utilizing only minimalistic kernel uh, to just see the internal body organs, to diagnose the disease, or like if you have surgeries to perform, you'll be sending it internally. So how accurate it is doing, how precisely, if you want to do some cuts inside the body, that is where like the camera with the camera, with the precise, if the camera doesn't perform good, if the hardware doesn't do good, it's a part of it. The master here is Linux, which is controlling the camera, right? So if it is not doing good, it's like we can blame the Linux, or like we can also, if you further investigate, if it is not Linux, we can blame the hardware component. That is how it works. So when you are into the development, Linux sort of thing, so Linux is booming in every domain. Even like in the military applications also, we are using the Linux. So it is compatible, and for every hardware, it is like minimalistic. So if you have only a specific application in your brain, you can definitely go ahead and use the Linux. So it depends on the feature you are developing, and you can only utilize that Linux for that specific feature. That's why we are saying it's a minimalistic thing we can use. So that sort of a scalability is supported by the Linux. That is why we have to and like we have to enhance our skill set in the Linux. Why That's why I'm asking you to focus on the Linux very hard. You can see the IoT devices like smart home controllers. Like you can see like nowadays every house will be having suppose the air conditioners, or like any smart home appliances like a Wi-Fi. So we'll be integrating all the smart home appliances so with the Wi-Fi. So we'll be staying suppose if we are like in some other city and if we are far away from our home and if you are just visiting your house after multiple days, if you want your air conditioner to be turned on by the time you reach your home, especially in the summer days, you'll be just before 10 or 15 minutes, you'll be turning your AC from outside. That's where like a smart IoT comes into the picture, right? So yeah, while developing such smart home controllers, the Linux is the one inside there, and you'll be using it. So yeah, these are the applications where we are using the Linux, and it's so guys, like please dedicate your time in terms of understanding these concepts. If you have any doubts, you can you can ask me like from here on. It's like a really uh, important thing to understand. So how the Linux boot when you power on your system, how Linux will be booted and how the whole system will be handed out to the user so that you can utilize the Linux. Okay, so as of now, you're okay, right? You're good, right? All good?
Yes.
Yes,
Okay, good.
yes, yes.
Okay, that's good. So the next important phase is a boot flow process. So how actually the Linux boot flow will work in our case is like for this I'm gonna use the paint. So if you can able to see my screen, please let me know.
Yes.
You can able to see it, right?
Yes.
Okay. So it would be really helpful for people how you have to like the mental model I'm gonna provide you. Just this please dedicate your 1 hour of this from 8 to 9. Please utilize this really. Okay. So this is how like I'm gonna draw some block diagram. Say you as an embedded engineer, you have to utilize. Alright, guys, like it won't. Please mute yourself. Someone is talking continuously. It would be like disturbing others who are listening carefully. Please. So this is the SOC, like a PS part. So this is the PS part. So in the PS part, when you see the PS part, the only two components you need to understand. The embedded engineer will see the whole SOC as a black box. So this is what he can able to see. This is as a whole black box. He really don't know. He really don't want to know what. It's a plus if you know the hardware components in that specific black box. If you don't know, it would be much appreciated. But he should know how the Linux boot flow works. But I'm go ahead and I'll explain what actually how he has to visualize the whole system here. Okay, so here it is like a CPU. He have to see the whole box like this. Okay, this is memory and this is CPU. Okay. Uh, I'm gonna explain you the ARM architecture here. It like not in much detailed way, but I'll explain in a way like just very basic way. I'll explain. So this is the CPU and this is the memory. So like the CPU will execute the instructions, right? So from where it will get the instructions, it will get the instructions from the memory, right? So how it will get the memory? So like it will be having one bus connected. Also, it will send the address here, and then it will send the instructions here, or like data. Okay, so CPU will send the address. So here, and the memory will be having the addresses. So in the addresses, like suppose if it points to some other address here, So the whatever the data is available here in this address, it will pull the information from this bus. So this is the address bus and this is instruction or data bus. It will be taken from this side and the address will be taken to the CPU. This is how the this is how it works, like in terms of the communication between the CPU and the memory. But if you have multiple, if you want to send data and if you want to get data from the memory, and if you also want to get the data instructions from the memory at a time, it would be hard to utilize the single bus in terms of sending this instruction and data. So what actually is doing is so no, like we'll be having one more layout here, we'll be having one more thing. So this will be sending this address and it will be taking the data from here. And this will be like, only for the instructions it will be using now. And here the data will be taking. So if it is having only one bus for the data and the instruction, it will be like a von Neumann architecture. Somewhere you have heard that name von Neumann architecture in your earlier days or in your bachelor days. So it would be like a von Neumann architecture when we have only one bus that is dedicated for both the instructions and the data memory. So that's the bottleneck. Whenever you want to get the both instruction and the data, it only at a time it can only get instruction or data, but we don't get both, right? So we'll be dividing. So what actually is like we have another architecture called hardware architecture. We have divided the buses into two components. So it is like the data bus. Sorry. This is instruction bus and this is the data bus. So this is from the data bus. If it sends the address here, it's gonna get the data here. Okay. And if it sends the address from this bus, it's gonna get the instruction from this side. So we have two different buses, right? So this is called the hardware architecture that is implemented nowadays. Every embedded application will be utilizing the same concept. In the olden days, we have one human architecture. Nowadays, we are using this hardware architecture. You guys got me, right? So,
Yes, sir.
okay. So, what I'm suggesting you guys is like, for the time being, I'll just suggest you to, keep in your mind. So you only have two components on the block. Actually, you have multiple components, but what I suggest you to remember is like just consider you only have two components, and that is the CPU and the other is the memory. Okay, so the memory, like the memory is divided into the and secure world and the non-secure. Okay, so this is the CPU, and this is the memory, right? So from memory, you can able to see only two components. You just visualize whenever someone is saying, just consider only the CPU and the memory, because whatever the hardware components I said previously, like we'll be having the hardware components in the PL part, whatever the IPs like hardware accelerators or like any something like any hardware accelerators or GPU or any SSD or any hardware component that will be like memory mapped to this RAM. So it will like whatever the data is available in the hardware component, any IP, it will be placing that into the memory so that the CPU can utilize it. So the CPU can't directly go to the hardware components and collect the data and process the data. So the intermediary thing is the memory. So when I'm saying the memory, can you guys say what is the memory here? Can someone say what is memory here?
Okay, it will store the data like
That is
memory.
memory itself will store
An
the data, right?
intermediate between PL and CPU, sir.
Huh? No, no. What I'm asking is like in
RAM.
your layman structure, you will be having your smartphone, right? So in whenever you what I'm asking here is like what is the memory here?
RAM,
When
sir. RAM.
perfect,
Read-only
perfect.
So
memory.
Yeah.
RAM.
So the RAM is the one I'm saying here as a memory. So most of you guys think what is the memory means, like it could be like the secondary storage. So we will never consider the secondary storage as a memory. Whenever you heard the memory word in the embedded application, it is a RAM. Okay, just consider it's a RAM. So whenever the RAM, suppose the OS is responsible. So the OS will be placed. So you got me right. So what is memory and how the CPU is connected to the RAM and how hardware components are memory mapped with the RAM and how the communication will be happening via these things, right? You got me right?
Yes, sir.
Okay.
Can you
And
give me one more time for this one, like CPU, memory, and PL? Just one more. Yes, one.
Srinivas,
Yes, yeah.
okay, Srinivas, I'll explain you.
Can you
So
explain one more
uh,
time for this one?
Yeah, sure, not an issue. So, I said, you just have to visualize the system with only two components for the time being. That is like CPU and the memory. Because in the previous slide, I have explained. Oh, sorry. Can I go back? I don't know whether I can go back for the previous slide or not. So you have the address bus and the
Yeah,
instruction bus, and
instructions
you have
and
one
yes,
more
yes,
address bus. Yeah,
yes.
so address will be sent and the data will be taken. So you will be having the data bus and the instruction bus. Okay, so this is how it works. The CPU will only integrate with the DDR or any RAM. Okay, so it will integrate with the RAM, and the RAM is like memory mapped with the hardware peripherals outside. Okay, so the hardware peripherals will be memory mapped here, and whenever the CPU wants to communicate to any suppose if you have any temperature sensor that is running, the temperature the temperature will be collected by this temperature sensor, and the temperature the hardware component will be having few register that would be mapped to the memory DDR map. It will be that sort of understanding. The register knowledge will be fed it to the CPU, so the CPU will collect the information from that specific memory. So this sort of communication will be established with the hardware components. So the sort of realistic communication will be happening between the CPU, the PL part, the hardware component, and the memory is directly connected to the CPU. This is how it works, okay?
Okay. Yeah.
And so this is how you have to visualize for the time being. And when it comes to the boot flow process, for so just give me a moment, it is getting loaded. Okay, so what actually is I have said, just consider only two components on the CPU, the CPU and the memory. Okay, for your understanding, I'm just labeling it as M, and here it is CPU. So, have you guys ever heard the word called ROM? Previously, have you ever heard?
Yes.
Yes, sir.
What is the purpose of
Yes, sir.
ROM?
Sir, the permissions are there only to read the document, no, not to change anything else in the document.
It
Okay,
stores the code. Dot text section is
Memory
inside the ROM.
ROM acts as a permanent storage.
okay. So what is the purpose of ROM then? If it is a permanent, like if you write something into that, it would be permanently stored and never allows someone to write anything into it, right? So the name itself is saying read-only memory. So you can't just write into it. You can just able to read from it, right?
Yes, sir.
Right. So then what's the purpose of embedding such a ROM embedded on the SoC? So
To store both of things.
what?
Uh,
To
ROM
store
stores the
both of them.
data because RAM is not capable of handling data once the system is turned off.
In that place, ROM is able to use to recover the data so that RAM can again work from the previous state from which the computer was turned off.
Um, are you sure?
ROM is non-volatile.
Actually, ROM is used to store the code that we flash on the MCU.
Bit correct, but uh,
Sir, it's
so oh,
the startup
mm,
sequence. So the
what was that?
startup sequence which is required for
What was that called? What was that called? The startup sequence. So you said like
bootloader.
Bo-
Sequence, boot up
Booting,
sequence.
booting,
No,
booting of
uh,
system.
like you can't say it's a bootloader. So but what actually is like a ROM? What actually it stores inside? How it is like what sort of significance does a ROM have? So you guys are giving partial correct answers, but none of them are like
Store the
correct.
firmware.
Exactly, Prem Kumar, you are correct. So
Yeah.
it stores the firmware that are needed for the system to initial startup. Okay, so suppose if you just press the switch to turn on, and from there on, what is the first piece of code that will start executing in the system is that's the ROM code. Okay, it stores the boot firmware, initial boot firmware into the ROM. You got me right. So it is like a non-writable. It's a single writable. It will be written at the time of the vendor manufacturing the SOC. At the time of itself, it is hard coded into the ROM. It will be never replaceable. Okay, it is like a fixed thing that will be writing into the ROM. What actually the purpose of writing? What is the purpose of ROM then? Who will be executed that ROM code? Okay, so the CPU is in charge of executing the ROM code, and the purpose of the ROM code is like it will initialize the bare minimum stuff, because you just power on the here. Suppose it's a switch. If you just press this power button, it will be powered on, and once you just enter the boot. Hello. Hi.
Yes, sir, audible now.
Okay. I just I'm not a pro in terms of dealing with this board drawing things, but it's okay. But I'll draw that for you again. So this is the CPU and the memory. So as I said, like here the ROM code will be there, and soon the moment you press the power button, the ROM code will be executed by the CPU, and the CPU will execute the piece of instructions that are defined in this ROM code. Okay, and the ROM code, what actually the purpose of running the ROM code is, it will initialize this, the SRAM part, the portion of SRAM, static RAM, and uh, static RAM is like a static. It's a RAM device. It is even though if you turn off the system. Someone previously said that the ROM code is responsible if the power goes up, if the power goes down. The ROM is responsible for the system to wake up from the previous stage from where it went to down. It's not the correct thing actually. So what is the purpose is the basic purpose of the ROM code is like to initialize the bare minimum hardware that are defined in the ROM code, and it will identify the first stage bootloader that are defined. So you'll be knowing like we have multiple bootloader storage devices like SD card. You can boot from SD, you can boot from eMMC, you can boot from QSPI, any flash drives like QSPI, OSPI, and if you have any other JTAG, you can load from the like when you have if you have any debugger, you can load that from the if it is you have any debugger you have launched, You can via debugger you can send them serially via JTAG. You can boot that, right? So OSPI and the QSPI and the eMMC and SD card. These are the boot components like a bootloader. Boot components where the bootloader will be stored. So via SD card, it is embedded somewhere, and the eMMC, it's MMC also embedded embedded on the board itself, and the QSPI latch it is embedded on the board, and the OSPI is embedded on the board. So wherever you can choose the whatever the boot mode if you want. So you'll be having the jumper switch. So the jumper switch by default it is set it to SD card or eMMC. So the switch will be moved across these components. If you just pull that switch to SD card, you're booting whenever you put the switch on, the boot code will be executed and the control will be passed to the SD card. So the boot ROM will identify the first stage bootloader, that is like FSBL, and it will be loaded into the RAM. So the DDR, the ROM code will initialize the DDR and a few clocks. So bare minimum hardware components will be initiated by the boot ROM code, and also its a primary job is to partially initialize the DDR. So and the second most important thing for this ROM code is identify the FSBL whenever you put the switch on. So this will be giving indication like it will be forwarded to this one, and if the switch is here at the SD card and the FSBL goes straight down to the SD card, and it will find the FSBL and it will load into the ROM on the ROM. It will be placed in the RAM. Sorry. So on the initial addresses of the RAM, it will be placed here, and the first stage bootloader will be executed. It will initialize the further hardware components that were initialized, whatever the hardware components initialized by the first stage, boot ROM. And the rest of the hardware will be initialized by the first stage bootloader, and the first stage bootloader will completely initializes the DDR, and the DDR is completely up and running now by the FSBL, first stage bootloader, and the FSBL is responsible for identifying the kernel image wherever the kernel image is available. If it is available in the SD card, it will also load this kernel image into the ROM. You till now you're clear, right? You got me right? Hello,
Yes.
yes, you are good. You understand, right?
Yep.
Okay.
Uh,
What
so
about Prem Kumar and Prince? Okay.
the
You have doubts, you
BIOS
can
is
ask me.
also a first stage bootloader, right?
Correct.
Yeah.
BIOS is it's a bootloader. First stage bootloader, it's a common thing. Okay, it would be like first stage bootloader will be loading. Uh, First stage bootloader, it's a bootloader, and the second stage bootloader is the BIOS. You can, it's a naming convention. You can say like the first stage bootloader, the second stage bootloader, and the tertiary bootloader is the third stage bootloader. And then I'll
Okay.
explain you in the same context. For the time being, just accept what I'm trying to say. Okay.
Okay. Got it. Yeah. Yeah. Thank you.
So I'll also open another new board so that like I'll make you to understand a bit more clear. So as you guys understand, the ROM initializes the partial DRAM, partial RAM, and the FSBL will be loaded from SD card here. So from SD card, it will load the FSBL here. Okay. So here I will label it as FSBL, and this FSBL will start executing from the zeroth vector. It will be start executing, and once it is executed, it will initialize the full DDR, and it will also initialize the hardware components that are there in the PS part. So all the hardware components will be initialized by the first stage bootloader, and it will find the U-boot or BIOS you said previously. It would be like U-boot is the one we are calling for the embedded applications. BIOS in terms of if you boot if your laptop, if you wants to boot your laptop, if you continuously from switch off, if you just turn on the power button and continuously enter the escape button, you'll see the BIOS menu. That's the BIOS that you'll be
Okay.
using for the x86 architecture like laptops. Okay, so that's the BIOS that we used to say. the U-boot for
Gotcha.
the embedded applications. Okay,
Okay.
and the
Uh,
BIOS
uh,
is for the okay.
yeah. Just to relate things. So in Windows, the OS code is stored in SSD or STD, and then that is loaded
Perfect.
into the RAM, right? So
Yes, correct.
similarly, here it is from the eMMC or the ROM.
because
It
because
goes
uh,
into the
because
RAM, right?
yeah, I'll explain. So it is not like it is not only SSD you can store the whole OS. It is up to you. So you have multiple components like if you just turn on the BIOS BIOS menu after powering off. If when you just turn on the power, you can continuously press the escape key or like F12.
Yes.
You will see the BIOS menu, right? There
Yes.
you can
Yes.
see the
Yes.
bootloader options. If you choose the flashable drive pen drive you insert onto your hardware, it will choose like you
Okay.
just move the arrows up and down. So just to choose which what's the bootable drive it would be like if it is like pen drive or like if it is like a hard disk embedded on your laptop. It would be your choice of selecting. If you don't enter into the BIOS menu, it would be your hard disk by default because your hard disk is in charge of storing the Windows operating system by default, right? So it would be
Yeah.
by default, it would be the option set it up in the BIOS menu to choose the bootloader from the hard disk itself. If it is STD, it's STD. If it is a HDD hard disk, it will be HDD. Okay, irrespective of the secondary storage that you have, it would be loaded. Okay, so how that
Okay.
is how it works. So you got the ROM. The ROM is partially initializes the this RAM and the after executing the ROM code, it will go and search for the FSBL from this SD card and pull the FSBL from the SD card and place it into the DDR. That's the job of that's the most important job of the RAM code. Okay, and after placing the FSBL here, the same thing will be applicable for the FSBL as well. FSBL will start initializing the full DDR and it will initialize all the clocks that are sending to the each and every hardware component. And once FSBL is about to terminate, its job is to identify the kernel image from the SD card somewhere, and it will be placed here into the DRAM. So this is the FSBL. It is executed, and the kernel image will be placed here. The second FSBL will identify the U-boot and U-boot will be U-boot, and in terms of like embedded applications, it is U-boot. If you just go ahead and if you have if it is Linux, if it is PC, personal computer or like laptops, it would be the BIOS or grub. So BIOS is the old thing, and the grub is a new Grand Unified bootloader. It's a new version of a bootloader. First, it's a new second stage bootloader that would be like taken from the SD card and it will be placed here. And the job of the U-boot is like it will identify the main kernel image. So its job is to evolve across the multiple stages. So first FSBL and second like U-boot and then first is BIOS and second is FSBL and third U-boot and fourth it is like a kernel image. So this is how the Linux kernel evolves. Like it is how the Linux boots. So from here on, the main Linux will be booted up, and so it will be having from here on. So I'll be saying like a U-boot job is to load the kernel image into the DRAM, and it is responsible for loading the kernel image here. And from here on, the Linux kernel starts executing, right? So the Linux kernel, what actually the U-boot will try to do is like the U-boot whenever it's trying to load whenever it is trying to load the kernel image from the SD card, uh, so, sorry, this is the RAM, right? So in the FSPL, it got executed, and then it will load the U-boot in the consecutive memory area. And then the U-boot job is to link the DTB. Here, the DTB is like device tree block. It will be having the hardware knowledge about the hardware components, So all the hardware knowledge will be a user will be writing into the DTB. So the DTB will be linked to the kernel, and the U-boot will pass this DTB to the kernel. So the kernel will be having whatever the knowledge, whatever the hardware components that are there in the system. All these hardware knowledge will be shared to the Linux kernel. so that the Linux kernel will be knowing that okay, I have GPU, I have hardware accelerators, whatever the hardware components that are defined on the DTP, it will be knowing that okay, these are the hardware components under my scope, so that I can utilize these hardware components whenever the user space application from user space, this is the kernel space. Whenever the user space application wants to access the GPU, so it will send a system call. So this is the divider between this is user space and this is the kernel space. So whenever the user space application, like any if you are processing any graphics from the user space application, so the whenever it needs the GPU under in the hardware, this is the hardware in the system. So if you have GPU here, if this user space application wants to use this GPU, it will send a system call to the system call will be sent from the user space. Then the user space will be switched to the kernel space, and the kernel, that is running from here, kernel is defined here. So this kernel will be having the knowledge, hardware knowledge via DTB. So it will utilize the kernel running from here to here, it will be tied up with the DTB. So the DTB will be utilized, and the DTB will be defined with the hardware information about the GPU that are running on the PL part, so that GPU will be it will be the user space application collab with the kernel to the hardware component like GPU. This is how actually the boot flow process works. You got me right?
Yes, got it.
Any doubts? So I'll explain. So here you can see like SPL, it's the boot ROM. So it will load the FSBL, first stage bootloader. And this job, the purpose of the boot ROM is it will identify the FSBL from the SD boot code. It will be every bootable images. The from SPL to the root file system, these everything will be, you know, these all the components will be stored in the SD card. So it will load the boot ROM will go and get the FSBL. It will be loaded into the DRAM on the RAM, on the initial parts of the RAM. And the FSBL part is identify the U-boot from the SD card again, and it will load into the DRAM again. So the U-boot will initialize the U-boot. The main job is like it will load the Linux kernel somewhere from the SD card. While loading the Linux kernel, it also provides the hardware information that are defined in the DTB. I'll show you the DTB when I open the Linux source tree. Okay. So this is how like U-boot provides the information about the hardware to the Linux kernel, and once the Linux kernel is loaded into the RAM and it is running up, so the root file system also loaded into the bootloader, like U-boot also loads the root file system into the DDR, and the kernel will have the information about the hardware. So from here on the boot, the Linux will be booted up, and the command line, if you can see the Linux terminal, it will be you can able to see once the complete system is booted up. You can able to understand, right? So if you have any further doubts, you can ask me now, because this is a crucial step. Every vendor wants to a candidate to be knowing in terms of giving them the job. So the bootable default boot source is here SD card. So SD card or any pen drive, bootable pen drive, or any MMC that is deployed on the board, embedded on the board, or any hard disk or a floppy drive, any from wherever DVD also we can boot. So whatever the hardware components like storage devices that we have, we can able to store all the bootable images from FSPL to the root file system, and we'll be having it, and we'll be loading that into the DRAM, DDR. So the DDR is in charge of in terms of executing each and every bootable image, so that the system will be up in the fashion how I explained here. So if you have any doubts, you can raise the question. So this is a crucial step.
So, does the SD card come into picture when the bootloader kicks in, or
Sorry?
is it before that? Does the
Sorry.
SD card come into
Mhm.
picture when the like U-boot kicks in, or is it before that, like the FSBL? So
So,
up to the FSBL, it is on the embedded device, right?
correct. So
Okay.
up to the so the FSBL is the first stage bootloader. So the FSBL will be taken. So the boot ROM I'll be saying, right. So for your understanding, I'll also draw the picture of SD card, how the layout would be in the SD card. So suppose if we have the SD card like this, so we'll be having addresses like this in the SD card. So somewhere around you have defined the FSBL here. Okay. So
Okay.
the boot ROM code that you have is it will goes to this address in the SD card. It will gather all the information because this boot ROM will be defined with the FSBL size, start address, and the ending address. So this start address and ending address, as this boot ROM, the API that are defined in the boot ROM code will be having the start address of the FSBL and the end address of the FSBL, and also will be providing the size of the FSBL. So it will taken that FSBL whole image from the SD card, and this FSBL will be loaded into the RAM here that we have the layout here.
Got
So
it. Yeah.
you got me right. So
Yeah.
FSBL
Yeah.
will be loaded here, and to execute this FSBL, we don't have the CPU don't have the direct access to this FSBL directly. So what
Okay.
actually the CPU have is like the CPU can access the RAM, so that the FSBL code will be executed by the CPU from the RAM context.
Got
It doesn't execute the code from the FSBL. You got me right?
got it. Yeah. Got
So
it.
in the same fashion, the FSBL when it is like executing, so it knows where the kernel the next U-boot is loaded.
U-boot. Yeah.
So yeah, you're
Okay.
in the same context, right? So you can
Yeah.
able
Yeah.
to visualize. So when it is dying, when FSBL is about to die, it will
Yeah.
load the U-boot from the SD card
SD card.
from
Yeah.
somewhere location. So that API will be knowing the starting address and the ending address of the U-boot, and also the size of the U-boot, and it will be loaded into the DRAM, so that the
Got it.
DRAM it will be loaded into the DRAM, so that the CPU have the privilege to access the DDR, so it will
DDR.
start
Yeah.
executing the U-boot, and when it is about to die, it will load the
Kernel.
kernel image. Yeah,
Yeah.
and it will also load the kernel image and the rootfs. For the kernel image, what information does it provide is the hardware information in the PL part. So, okay, kernel, I'm about to die. When I'm dying, I'll provide you the information about the hardware that you can able to utilize. Suppose the GPU is defined here, and the memory registers like you can memory map. So the GPU will be connected to the DDR with the like the memory mapping will be done with the kernel. So you can
Got it.
these are the memory registers you can directly contact to the
Got it.
GPU or any
Yeah.
GPIOs. So IO communication with the actual hardware, such sort of
Okay.
information will be provided by the DTB, device tree
Okay.
block. Okay, so that
Okay.
maybe tomorrow I'll be showing that how DTB is defined, how DTB data structure will be writing. So the kernel
Okay.
utilizes the DTB. So the DTB is a roadmap for the hardware. So it will be knowing
Got it.
that okay, these are the hardware components I'll be knowing. So so I can contact to the GPU via these memory registers that are mapped to the DDR. So that I'll be writing the info into the DDR mapped registers, so that the DDR, GPIO or GPU, it will be taking information from the memory mapped registers, so that the communication will happen in such a fashion like that. Okay.
Okay. So the root FS is also part of the kernel, or it comes as a separate package, and how does it
Uh,
work?
yeah, the rootfs, it's a like rootfs, it's a separate image. It's not a part of kernel image. So what
Okay.
actually is the rootfs consists of, if you just open the Linux terminal, you can able to see, I'll show you the pictures
Yeah.
for your easy sake of understanding.
Sir, today's session only for this boot up only, no? Tomorrow we
Yeah.
can show the Linux commands and is it
Yes.
correct?
Correct. Correct. Correct.
Okay.
So you just don't drop off from here on, because it's really important to understand. Okay.
Okay.
So
Yes, yes.
this is the root. So will be this is the root where initial root file system. This is the starting point. Uh, so if you can able to see this, under this slash you have bin here, binaries, all the binary user space binaries will be defined here, and the slash dev development sort of things will be defined here, and etc is you will be having the root files. It under etc you will be having fs tab, that is like a file system. You'll be knowing that FAT32, ext2, ext3, ext4, such sort of fat file systems are there, right? So such
Yeah.
sort of algorithms are the root file system. It's how to say is I'll explain that as well by drawing some. So if you just go here, and sorry guys, I'm just taking the new board again. So um, the root file system is it's a kernel image. It's a we are loading at some portion here. So this is the root file system. I'm just embedding. I'm just deploying. I'm just loading the FSBL U-boot and kernel image. It's just like it doesn't even consume 20% of the whole DRAM. Okay, you do you it might be creating an assumption that all the whole RAM will be accumulated with only the bootable images. It doesn't even consume if this is the RAM, only this portion will be having the boot uh, at least like 10 to not even 10-15%, less than that, for our kind of understanding, it will consume only 10 to 15% of the whole DDR storage. The rest
Okay.
of the things it will be given for the user space applications. If you want to run any user space application, the kernel paging, memory mapping will be done from this from this memory. So this is only utilized for the boot part, booting purpose only. Okay. And so the root of if you consider the root file system like this, so if it is the DDR, if I load the root file system from here to here, the root file system, this is we call it as like a init ramfs or init RD. It will be mapped slash. This is slash is nothing but any block device. This will be mapped. How to say this? Uh, uh, So you have loaded the root file system here, and this root is the root file system. So this root slash represents this whole. Okay. So
Okay.
where you will be mounting this slash. Suppose if you have any MMC slash dev, I have shown
Okay.
you dev previously, right? Under this, some block devices will be defined MMC BLK
Yeah.
0 or
etc. Yeah.
yeah, BLK 1 MMC and something like that will be having the block devices. Suppose if you have created the partitions from this one, block one, MMC block one, and partition one, and partition two, and suppose if you have created the partition for 500 MB, this 500 MB, if you want to mount, it is the kernel choice to mount this root file system. So this slash, this is the replica. So this will be mounted on this slash dev MMC block one partition one. So
So
if you just okay, this is the sort of mapping. So
yeah.
if you just slash dev, it is this is how it maps, like it will be loaded into the root file system, and this will be mapped the slash root slash will be routed like a slash dev slash mmc like this.
Okay.
Okay. And under this slash, you'll be having from slash, you'll be having the user and the bin and etc and a lot many things like this.
Yeah. So this also begins at a specific address, right? The slash.
Yes, correct.
Uh,
You can able to understand this here, right?
yeah.
So yeah, so this is how the boot flow occurs. And if you have any further doubts, you can ask me now.
So in
Like
the start,
Mhm.
uh, you mentioned about the add-ons that go on to the kernel, right? So suppose if I am having a system where there is no display, but I have some audio
Correct.
feature,
Yeah, yes, yes, yes,
and
yes.
so that comes as a kernel package that is loading after the U-boot, or is it part of the root FS? The additional
What
features
you
that are
said?
there. So whatever
No, no.
additional features have,
Mhm. That
whatever
are like,
additional fe
additional features in the sense like you'll be having the hardware component. Suppose if you have if you want to use some audio, so
Okay.
audio in the sense like if you want to listen some music, so how it works is like the user space. Suppose if you launch a Geo7, or like if you launch any specific application to play music, so that thing, like if you have if you want to utilize the speaker is the actual hardware. So whenever you launch that one, if you just play any song from JioSaavn, then it is the user space application. It will be switching to by a system call. It wants the hardware, right? The hardware is nothing but the speaker, so it will make you to listen the songs from the hardware, right? So from user space application, it will switch to the kernel space, and the kernel invoke the
Uh,
specific audio drivers for you, and the audio drivers will be collabed with the kernel, so that the user space application will send whatever the song lyrics and tunes to this driver, so that the driver will send that to hardware, so that you can able to listen the music. That is the flow
uh,
it works.
so the driver comes as a package of the kernel that we are flashing.
Perfect. So
Yeah.
that is the part, like that is somehow advanced concept that if you want to cover, it would be like the course that will be joining. But this is for the job specific thing, right? So the boot flow itself is really important for the people to crack the job. That's why we have covered the only the boot flow for now, and tomorrow we'll be like compiling the images for the system, and we'll be loading that images, and will make the system to up and run. That is what the agenda. So if you want to excel the drivers part of things, we have a very nice sessions, and we have a good way of making you to understand how the Linux kernel modules will be loaded, and the layout, the structure for the skeleton, how to
Yeah.
develop the character driver and the network driver, block driver. So that is pretty much covered in the program. If you are interested, you can join, or else like we have an interview again for the people who are shortlisted for the 10 positions, right? So it would be
Yeah.
like that. So if the interview is demanding such thing, we'll be getting the info from the Prashanti. Again, I'll be discussing with her, so that if the such things are needed, I'll be also explaining that thing. So
Sure.
our main agenda is the people to crack the job.
Got it. Yeah.
Yeah, you got me right. So that is what
Yeah.
how we
Yeah.
are
Yeah.
planning.
Uh, are we also like looking at the Linux source code and trying to understand in these sessions, or that
Yes.
is a separate task?
Yeah, this is, I'll also, we have 10 more minutes. So this is the Linux source tree. So actually, the kernel, the whole kernel will be compiling the kernel here. So the kernel image is the master for the Linux, right? So as I said, kernel multiple times. What is kernel? Kernel, if you just consider a car will run without engine. Does a car run without engine? It doesn't, right? So the same, the Linux kernel, Linux is the operating system, and the engine on the Linux operating system is the kernel. So the kernel is responsible for driving the whole system. Okay, that's how you can visualize the Linux kernel. If you can see, like this is the source code. He's the one who have invented the Linux Torvalds. He's the one who have developed the Linux. So in early 90s itself, he have developed this Linux operating system. So it changed the world, the computer world. So he have used the C to develop the whole Linux system, Linux operating system. Okay, so if you have got some time to study about him, you are pretty much welcome to open, yeah, what's that, like your Google. You can search for his name, and you can study about how Linux is developed from Linux towards. Okay, and so when you just dig into the Linux source tree, here I'll cover a very important five directories here. So I'll cover the Arch. Arch is nothing but the architecture, the CPU. Suppose I said BeagleBone previously, right? So the BeagleBone is the one where we flash the images, and that is the actual hardware that we have. We'll be booting that images, right? Okay. So what actually how when we are compiling the image for the
Sorry,
BeagleBone,
sorry,
how
one. We have one question first. Sorry.
Mhm.
You're talking about BeagleBone, some microcontroller. There is a microcontroller that is.
It's not for microcontroller. This is like the Linux embedded Linux where we have multiple cores running on. Microcontroller will be having only one core, isn't it? Like
Okay,
it
that the single board computer like something SBC.
exactly. Yeah, that's correct.
The BeagleBone Black something.
The BeagleBone back is it's a multi-core, so we'll be having multiple cores running on it.
Yes, yes.
So to just control that multiple cores, one master we are installing. That's the master, nothing but the Linux. So the Linux is in charge of handling all the multi-cores available on the BeagleBone. So the Linux will be having the kernel, right? The kernel will have scheduler. The scheduler will schedule the jobs to run on which processor to take care of the process that are to be run. So the BeagleBone is different from the microcontroller.
Okay, is supporting the Linux 6.1.8 also that board? Linux.
Uh, for the Linux,
Yeah. The Beagle
sorry.
Black, the Beagle board something you were talking
We
about that.
as of now, we are not testing the 6.18 kernel, but
Okay.
we'll be flashing some version around 4, or like we have separate packages that are defined. And suppose if you just go to any that are like defined somewhere in the Google, right? So if you just want to download the source code for the BeagleBone, we can download it. So it's of like the agenda of our course is like we are not going with the new latest kernel that is available in the market right now, but we'll be focusing on 4.14 or like 5.18, something like that. So we'll be using such versions, like old versions.
Hello,
Okay,
sir.
okay, thank you. Yeah.
Hello.
Are you provide any training for this one, BeagleBone,
Yeah.
these things?
So soon after we finish this webinar, we have a well structured and well programmed program on the BeagleBone. So we'll be
Yes, sir.
writing some few drivers over there, character driver
Yes,
and
yes,
the network
yes.
drivers,
I think
and we'll be
yes,
writing the
correct.
driver.
Yes,
So
I was looking
we
that
have
one only, majorly.
yeah,
Yes.
so we'll be mostly like we'll be writing the drivers, and we'll be loading that driver, and we'll check the functionality of the driver that we developed. So
Yes.
that is the point, that's the more advanced thing, right? So for that, you to achieve to start working on developing the Linux device drivers, the basic requirement is you to write some bare minimum C stuff, so you can able to understand the pointers, and anyhow, like before going over there, I'll be covering the core concepts that are needed for the driver to implement. So it's my responsibility for you to understand the core concepts, that C core concepts that are needed for the person to write in the Linux device driver. So yeah, so it's a boost on your profile. So the moment when you have like when you have learned the process of writing the Linux device drivers, it's you on your career like boost like anything. So as I have said previously, right? So to excel something in the master in the embedded thing, so you will be it would be won't take much time, like the way suppose if you want to learn the Verilog in VLSI sort of thing, it will be taking a huge amount of time, but it will pace you off. So the time you invest in terms of VLSI, the amount of time you invest is directly proportional to the money you earn by placing somewhere in the job. But the thing here in the embedded systems is like when you invest your quality amount of time, you must be a problem solver rather than like if you don't even have the prerequisites like C language in the embedded systems. That's okay, because the in charge will take care of you to make you understand the things, right? But the problem solver, whenever you see the problem, irrespective of the logic, if you are good at writing the C logic, or else if you are good at writing the Python logic, or it's you, right? Finally, you have to solve the problem. If I ask you to solve the problem, suppose if I give you in a binomial expression to identify, like suppose if I give you the quadratic expression to identify the roots of x, suppose if I say x squared plus 5x plus some value like 6, so I just ask you to find out the roots of x. So you have to identify the roots of possible roots of the x and put me that. So I want you to be like that. So in terms of you have to think different ways to get the solution for the problem, and the rest will be taken care by me. So you will be writing the drivers at some point of time. So that is how it works, right? So I want everyone to be like just make yourself comfortable in terms of solving the problem. I hope you got right.
Sir, small doubt.
Yeah, Manikanta, please.
Now, what flow you explain? No, as of now, I understood like it is same like Peta Linux. May I know
Okay.
what makes difference between Yocto and Peta Linux?
That is really simple. The petal Linux, the word you are using is like might be you're some sort of working with the AMD, I guess. Like it's a AMD sort of thing.
Yeah, it's AMD tool only.
Yeah, so like in the AMD, it's a Peta Linux. The Peta Linux is developed on top of Yocto. So as I have said previously, so I'll 1 second. Yocto is under down. If you go down the layer, it is Yocto, and on top of Yocto, you'll be developing the layers for like a. So this is the Yocto. On top of that, you'll be creating the wrappers. Okay. So these wrappers, what actually will do is like if the Peta Linux build BSPs are there, that Peta
Yes,
Linux build you'll be having the BSPs up to Vercel, if I'm not wrong.
yes. Vercel on
Jink,
the latest one.
yeah, Jink MP, and
Yes,
Vercel, up to Vercel and VercelNet, you have the Peta Linux build BSPs. From Telluride onwards, you won't be having the Peta Linux BSP. You will be having EDF flow. So you'll be using EDF flow right now, right? So
yeah.
so this EDF flow is completely based on the Yocto. So you will be using the Yocto for building the BSPs for the Telluride. So the previous stuff that you have dealt with the Peta Linux. So this Peta Linux was built on top of Yocto. So the complete flow that where you use the Peta Linux and the Yocto are same. Whatever the workflow you have, but the Peta Linux you have extra features like it can boot the board. Booting is possible with the Peta Linux, and also like you can simply like change the configurations like while you are building the kernel. If you want to
Yes,
config the kernel configs, you can able to do that.
that customization
You
we can do.
Yeah, so it is really easy for people to use the Peta Linux when you are habituated the Peta Linux. But the Peta Linux was built on top of Yocto itself. So now what is
Sir,
happening is like we are taking off all these wrappers and we are simply using the Yocto itself. So this is like the EDF flow.
sir, here in Yocto, each layer we need to develop, or while compilation itself, it will build that kernel image.
So,
How
okay,
it
that's
will
a
be?
good question. So, like, as I said, like Yocto will be having the recipes are there, recipes on top of that, the layers are there, on top of the classes are there. So, if you just go to, suppose if you have Meta AMD, something like that, if you have the recipe, like Meta Adaptive SOC or like something like that, there, if you ever built some Yocto recipes from the EDF flow in your organization, you'll be having such layers are there. If you just go there,
Yes,
recipes are defined under that one. So if you just bit bake, suppose if you just bitbake some specific recipe, it will connect it to all the recipes and it will create all the bootable images. So you can able to load the boot dot. Suppose you will in the Peta Linux you will be generating the boot dot PDI, right? So that
Boot
boot
dot
dot
pin,
PDI,
yes.
whatever it might be, pin and PDI both are same. Okay, so whatever the boot dot bin you are generating, it will be generated and you will be like flashing that one so that the system will be booted up like anything, right? So here the EDF flow is also the same. So you'll be generating, if suppose if you bitbake a EDF Linux disk image or like EDF Xilinx boot bin, something like that. If you boot that one, you'll be having all the images that are specific to the bootable images that are required for the system will be generated, so that you'll be using that one and you'll be creating the WIG image, so that you'll be loading that WIG image into eMMC or like SD card. So from via SD card, the flow is same. But the way you have used Yocto in the conventional method I have explained here, right? So the
Yes,
Linux
sir.
image, the U-boot and the FSBL will be compiled from the tool chain in the conventional method. If you are using the EDF flow or Yocto flow, you will be compiling via BigBake. That is the build system
Yes, sir.
will be taking care of big baking the recipes. It will generate all the recipes that are needed so that it will be loading. You'll be using the images to boot the system. You got me right,
Yeah,
Manikanta?
yeah, understood, sir. Thanks. Yes, sir,
Yeah,
understood.
yeah.
Thank you.
So, any more doubts? Okay, the Linux source code is here. So before coming tomorrow session, you guys might be knowing the ChatGPT. Nowadays, you people are really smart in terms of utilizing the ChatGPT or any other AI. So just ask your ChatGPT to explain the Linux source tree. What are the major components of the Linux source code? So here the Arch is responsible for the specific hardware that you are developing. Suppose you might be knowing ARM64. ARM64 is the one, it will be having the configs here. So that these are the configs that are defined. So these configs, based on the configs that we have defined here, is responsible for building the hardware component and the kernel image. Okay. So these configs, whatever you define here, so these hardware configs are responsible for building the kernel image. Suppose if you have PCI Express, if you configure that PCIe, you are saying that the PCIe is available. So if you say it's a Y, it's a static module that will be built as a part of kernel image. If you say it as a M, it's a dynamic module. It won't be built as part of kernel image. It will be built into the root FS, so that the root FS will be having this as a module. After booting the Linux kernel via terminal, you can load these NFC, NCI, something like that, NFC related sort of thing. So the ARM64 and microblaze that is relevant to Xilinx. And if you go deeper and if you can see, these are the hardware components like hardware that is supported by the Linux. So Arch is the one architecture, the CPU based on the CPU architecture. This ARM and ARM64, what's the sort of difference it have is like ARM is for the 32-bit and ARM64 is for the 64-bit. The BeagleBone is based on the 64, so that we'll be using the ARM64. Okay, so this is how we use. And ARM64, if you go deeper, here. These are the based on the configs that are defined here in the ARM64. These configs will be utilized so that we'll be compiling that kernel image. And after Arch, you have block. So block devices is like, we'll be having blocks of data. So whatever the data, all the algorithms that are defined for the block devices are defined here in the block. And when you go to the crypto, so crypto is nothing but the security features. Previously, someone said like as the Linux is the source code, Linux is the open source. How can we implement the security features? So these are the security features, security-based algorithms that are defined in the crypto, so that we will be utilizing such APIs to just perform our security features if you wants to implement. Hope I explained your question. I don't know her name, who is asked. Pravina, something like that. So this is the important part where you have to concentrate. The drivers I said previously. So whatever the driver, suppose someone have asked about the audio driver previously. If you just open the user space application, so if you suppose it's a Geo 7, so all the if you want to listen the music, if you just just go here and if you just open here the Geo 7, if you just open the Geo 7, sorry. So this is the user space application I'm running from the Chrome. So that this Chrome, if I want to play music from here, you can play the music. So how the background stuff for how it works is like, so it will invoke the kernel driver respect to with the hardware connected specific device driver from the kernel invokes such a hardware device driver that are specific to the sound so that the user space application will send the data song info to this driver so that the driver will send that to the sound hardware, so that will be playing the music for us. That is how it works. So so the drivers is responsible for doing the same. I hope you got right.
Yeah, got it. Yeah.
Okay, so the drivers will be having lots of important things here. So I2C, I3C, and IIO. Okay, and IRQ interrupts, and also like you can see like hardware monitoring, GPUs you might be knowing that, right? General purpose input and out. Okay. Oh, sorry, GPU is the graphics processing unit. GPIO is general purpose in and out. So all what whoever the open source community, development community is there. Whoever suppose a developer have developed some feature on GPU, so it would be pushed here. So it is really hard to accept our patches into the Linux open source community because we need to satisfy the hardware specific. It have to be adopted by the all the hardware vendors. It have to be compatible because we are making Linux is compatible with the hardware what actually we are working on, right? So for to make it compatible, so the feature that we are developing on the Linux, it have to be compatible for every hardware. Okay, that's why we have to satisfy lots of vendors. Okay. The drivers part is really important. If you go here, NVMe, it's a PCI sort of thing, and you can see like it's a performance monitoring sort of thing. Performance drivers will be here, and there are lots of drivers, even RTC, real-time clock. So for the real-time clock also, we have buses defined here. SCSI, it's a UFS sort of thing, universal flash. And if you just go down, SPI, it's a serial peripheral interface. So these are all the thermal monitor, like thermal drivers are there. So to just if you just connected some thermal sensor, it will be like this. The driver will try taking care of them. So USB drivers are there. Okay, so UFS is there, universal flash system, and lots of drivers are there. So if you want to excel any part, if you'll be pretty much like if you understand the concepts of kernel and if you want to dig bone about the any driver, you are like you'll be doing like you'll be earning good amount of money. So if you concentrate any drivers part, for example, hello,
Yes.
any doubt?
No, you're audible. That's
So if you just open the net here, net is like network related stuff will be there. All the network related drivers will be here. The Ethernet is responsible for assigning the IP on your system. So it is responsible for establishing the connection, internet connection to your system, right? So the Ethernet is here. So under this is the network. Under network, you'll be having the Ethernet and IP, IPA, IP, the IPv LAN. So all these sort of things will be defined here. Okay, so this is how the architecture defines, okay?
uh, so
And
uh, Over the time, do we have to gain expertise in specific set of drivers, or is it possible to gain much
You
exposure
know,
through all of those?
yeah. So, there would be some fields, not a specific field, because the Ethernet driver, for example, if you just consider the Ethernet driver, you don't just
Yeah,
rock the Ethernet driver, even if you spend years of ages, ages
yeah,
and ages if you spend on it, because Ethernet is the one. It was developed by multiple developers. So, a lots of developers developed together to form an Ethernet driver. So if you want to excel, you can able to excel the Ethernet just by contributing something. If you suppose if you are working in your day-to-day life in your organization, if you are working on Ethernet, if you don't know, if you want something really bad to implement on the Ethernet on top of that, so you just push the patch from your side to the Ethernet driver. So you can able to do small modifications on the big
okay,
Ethernet driver. You can't able to
okay,
excel the whole thing. So when you're working
oh,
multiple days on something, you can able to excel it. So just what is our purpose here is to make you to understand the skeleton that are needed for writing the driver. So the basic
okay,
drivers here are like network drivers and block drivers and the character drivers. So in this course, that is where even if you go any organization, apart from this, you can't able to get it. So even like some people will make you to understand the C, and suppose if you consider any outside courses, they'll make you to understand the just boot flow and how Linux works. So they'll explain how the Linux source code, and that's it. Apart from that, they'll never teach you the Linux drivers. Some organizations will teach you, but my agenda here is to make you to understand the Linux skeleton. So the driver skeleton, how the device driver is registered with the file system, virtual file system, and how the communication will happen across. So those are the things we will be teaching. So the moment when we have developed the feature, we'll be testing on the BeagleBone. The hardware is available with us. So so it will be configured, and we'll be running the system like anything. So I'll make you make you to understand the concept. It will be visualized to you while utilizing the real hardware. So that is how the
uh,
agenda of the course. Yeah.
are we, will you be simulating it, or you'll be showing the hardware?
We will not be simulating. We'll be directly running that on the hardware. Simulation is
Okay,
the part like suppose a chemo is there, like virtual emulator. It's a virtual emulator. If you want to
okay,
run some sort of, if you want to check, you can run on the virtual emulator, but it's not on actual hardware, right? So you will be
yeah,
flashing all the, you will be configuring the on the virtual platform. The actual hardware you will be configuring on the virtual platform. It's not an actual hardware. But here we have actual hardware that is BeagleBone. We'll be running all the drivers that we are developing and making it to work for us. You got me
okay,
right?
yeah, got it.
Yeah.
So the course for selected candidates, will that be like free, or there will be a fee for that?
What was that?
Uh, Once you have selected the candidates, right, shortlisted them, so will there be a fee for that, or?
I'm completely not sure about it. You just need to ask that to the Prashanti. So she'll be knowing that because uh, none of the people will do. It's my out of my personal experience. I'm saying this powerful stuff. This is the stuff everyone have to do in their day-to-day life. So it will
Yeah,
make you to understand the whole Linux boot flow process and the booting. How like you will be building the images, the bootable images, and you'll
yeah,
be loading that. So like none of the people will teach you this stuff, this valuable stuff for free anywhere in the internet or somewhere. So, I don't think, I don't want to make any conclusion on top of that. So it's like
oh,
a Prashanti. So, she'll be, it's a guaranteed job thing, right? So, the interview will be very complicated. So if people are if people can able to crack that, via a ProV Logic, you'll be placing in some organization. It would be like
okay,
Prashanti. She's the sole proprietor for this company, isn't it? So you have to discuss that with her.
okay,
Okay.
yeah, yeah,
I'm
sure, yeah.
yeah.
Mm.
Any question? When will class ended? If you want, you can drop off. It's your choice.
Sir, in bootloader also QUME evaluator is there, right?
Uh, yeah, QEMU is there. QEMU is like a virtual emulation. So the hardware will be configured virtually on the QEMU. You can launch the QEMU and you can configure your hardware on top on the QEMU. And if you want the system to be loaded with the kernel image and root file system, you can up and run your system from the QEMU. Like most of the companies are most of the companies will never directly start preparing their chips by default. They have to check. They have to check the hardware actually how it is working or not by the Q emulator like Camo or something like that. So they need to flash the images on that, and only whether they confirm if it is good and running, then only they'll start preparing manufacturing the SOCs. So that's what the significant sort of importance that the what that like emulator will have. So if in the hardware, the people write the netlist and it will be dumped into model sim or like tester sim just to run the simulation. So they'll be running it, right? So that is how on software also we have emulators called Chemo. So we'll be running on top of it. Any other doubts? Okay, guys, like she'll be creating one WhatsApp group and she'll sending it to you guys. Like for the if you guys the only thing from your side you need to do is like people who are interested in terms of joining attending the interview. So one small exam will be there. If you can able to clear that exam, that then the people will be called for the interview, and then we will be we'll be taking the interview. I'll be one of the panel member, and I'll also have a few more connections with the people who are working in the top organizations. Trust me, guys, like this is a very good opportunity. You'll never get it for free outside. Just utilize the opportunity. If you are capable, just make yourself like no one is the pro in everything. Just if you just got the time to understand, you just got some time to understand the stuff that are teaching in this 3 days webinar. And while utilizing this thing, and you just have some coding skills, even if you don't have the coding skills, if you have understanding, we will make you to make you what sort of coding questions you can expect from the real interview point of time. So we will help you. We will push you to the next stage, and in terms of like making you to understand the concept, and we'll teach you how the things are working, and this is how it works. And it is completely ProV Logic's responsibility in terms of pushing you to the job.
Sir, offline interview or online virtual interview?
Uh, like the initial round of interviews will be virtual, and then the next rounds will be like it would be like the vendor choice. The vendor won't conclude you in the very first round, but they will consider they'll ask you to attend 1 or 2 rounds of interview. The first round will be some sort of low-level programming, very basic questions they'll ask you. If you can able to clear that, that is our responsibility, isn't it? So they'll also forward you for the next round. So the second round will be like maybe like it's a vendor. They'll ask you to visit the office, so it's their choice. So yeah, like even Provilogic have placed a few people previously from embedded systems. I don't. It's like a 6 or 7 members got placed. So if you don't have any further more doubts, I'll drop off right now. So if you have like she's gonna create the WhatsApp group so that you can join over there. And any questions, so you can post over there.
Yeah. Thank you, Banu. Help
Thanks,
me
thanks,
relate to
David.
daily task. Yeah. Thank you.
Yeah, great. Bye.
Thank you,
Bye.
sir.
Thanks, everyone. Bye.